Hello. Okay, it's only me.
Hi, everybody.
Hello.
Hey, Thomas.
Oh, hi,
Hey,
Greg.
Ken, Dan, everybody.
Hi.
Hey, folks.
Hey, hi, Dan.
So shall I share my screen? I found a button to press. Any preamble?
You can. Hey, Ken, thanks for joining today. I'm chairing today's meeting, and we usually start a few minutes late because it takes people the first 3-4 minutes to kind of roll in. So I'll give you a quick intro when we get there. But for the next few minutes, I think we'll just sit still here and let some of the regular folks pile in.
Okay.
By the way,
Uh,
Greg, can I steal 2 3 minutes, no, 2 minutes, at the very beginning of the call to do an ad, insert ad about the attested TLS workshop. Trying to.
Sure. Yeah,
Okay.
that's great.
It's really going to be very short.
I'll hold you to it. I've been promising Ken the full hour for the last month and a half, so I don't want to cut him short. Last I saw, he had a pretty big deck, and
Mhm.
I warned him he
it'll
may
be
have to
fine.
come back.
It'll be fine. As long as people are prepared to ask questions, preferably at the end, but in the middle, I think I've got time.
That's probably good to establish up front. You want people to hold their questions for the end?
I kind of prefer that, but if
Sure.
there's something that stops them understanding what I'm saying, then they should stop me there and then, and I can clarify.
Sounds good.
So I have to tell you, you can't actually post your advert until I've held an auction. In fact, in TEEs to establish who's going to bid the most for this space to have the advert in. And there might be somebody else on call that's prepared to pay more for the 30 seconds of time than you are. So
I didn't quite follow that. I was looking over at the chat window, and I sensed that I was being informed that somebody may outbid my ability to ask a question by paying more money
that's
or
right.
something.
That's right. That's what I'm working on at the moment. Is in fact a thing called Privacy Sandbox or Protected Audiences, which is all about running auctions for adverts in TEEs. It's not what this talks about, but I thought I should try and get the joke in. It's fallen flat, so I apologise for my poor job.
I think it just went over our head, or my head, I'll say. Yeah. All right, we got a good set of folks here. It's 4 minutes after the hour. We got lots to talk about today. So two items on the agenda. One is Thomas wants to take a couple minutes to speak about. I already forgot. Sorry, Thomas. And then we have Ken Gordon from Microsoft, who's going to share with us some of the details of how confidential containers work in Azure, and I believe in particular some about how the policy language can be used to enforce what containers are allowed to load and how that kind of looks to a relying party. But I'll turn over to Thomas now.
Greg, should I go?
Yeah, go ahead.
Okay. So I'm trying to organize this workshop about the attested TLS POC, the project that we're running in the SIG to extend the TLS handshake to add native attestation credentials as first citizens in the TLS protocol. And I'm trying to organize that at the upcoming Linaro Connect, which will be in Spain, Madrid, between the 14th and the 17th of May. And I'm aiming at a full day workshop, basically to do a couple of things. One is to socialize the idea and the state of art of the prototype and the spec and the formal verification and whatnot with any interested parties. And the second thing is to pull together the team that is working on the spec, on the formal verif and implementation together to get some high bandwidth get together. So I'm going to start a thread on the Slack channel about this thing. And so if you're interested in participating either in person or remotely, please chime in because this is critical for me to try and understand the figures and tell the organizers how the thing should be set up. And of course, tell your friends. Yeah, that's it. End of plug.
Cool.
Giving it back
Thanks,
to
Thomas.
Yep.
Yeah, thanks. So I think I caught the topic, and for anyone who's interested, I think the main point is keep an eye on the Slack channel for more details on what Thomas is trying to organize there. So thanks, Tom. So the second topic on today's agenda is Ken Gordon from Microsoft talking about confidential containers in Azure. So I've been working with Ken for a few years now, and I know he has a lot of knowledge in his head. So we'll see what we can unlock from him today. Ken, I'll turn it over to you now.
Thank you very much. Just do the screen sharing business. And hopefully, okay. So I'm Ken Gordon. I work in Azure Confidential Computing. Previously, I was part of Microsoft Research in Cambridge, where we did most of this work. Many of these slides are stolen from Coworkers there. Confidential ACI is an Azure service that provides serverless confidential.
Ken. Yeah, I'm not seeing any slides. I don't know if other folks are, or if you projected yet.
Sorry, I thought I had, but you're indeed right. There was no. I have to select the box, which is that one.
And one more note, we've had some folks join since you last announced a few minutes ago your preference on taking questions. So if you want to just briefly cover that before you jump in, that'd probably be good.
Yeah. Thanks. Can you see the slides now?
Yes. Yes, thank you.
Yep.
All right. Okay, so I'll start again. I'll talk about the timing in a second. So I'm Ken Gordon. I work in Azure Confidential Computing. I used to be part of Microsoft Research. So confidential ACI is an Azure service that provides serverless confidential containers. We run the infrastructure, and then the customers bring along their containers. I think the slides will take 20 or 30 minutes, so I hope there'll be plenty of time at the end. But do stop me if I need to explain something, because some of this stuff's sort of self-referential and complicated, and you might say, hang on a minute, what do you mean when you said that? So we can start with Elco. Elco is Linux containers on Windows. It's a pre-existing Microsoft technology that allows Linux containers to run on a Windows host in a dedicated lightweight VM. Containerd then runs on the host and provides image layers to the guest VM, and that Containerd responds to the usual CRI interface that Docker and so forth have pioneered. In the guest, an agent reconstructs an environment that looks more or less like the run C environment that you would expect from Docker running on a typical machine. So our delta for doing confidential is these items. Our goal was to produce a simple to use but properly confidential platform. The existing Hyper-V isolation and minimalist Linux kernel and user land was a good start for us. We as a team, we'd done work with SGX-LKL, and we knew some of the challenges of custom runtime. So what we wanted to do was to be able to run workloads, off-the-shelf workloads like the NVIDIA Triton Inference Container without it being very difficult. So we use AMD's SEV SMP to protect the memory of the VM, the guest VM, to measure the initial state, which is essentially the kernel and user land, and to provide other evidence. All the host interaction is via guest agent. This is where we can control what the host can do to the guest. And of course, our aim is to prevent the host interfering with the guest, stealing secrets, and so forth. This is an attestation report from a AMD machine. The two bits that really matter to us most are the measurement and then the host data. So here, host data here. So the measurement is basically a measurement of the initial initial state of the virtual machine. It's measured, all the blocks, a bunch of blocks are measured, some of them are not, but mostly they're measured, and it comes up with this value, which is unique for a given image. Then the host data we put a hash in there that's bound to the hardware by the host side, and that's a hash of the policy that we're going to use to control the UVM. So if we go back to Elco, this is what Elco looks like. You have a physical machine in blue. We have a number of L1 VMs hosted on it, 3 in this case. And then in any given L1 VM, there can be a number of these utility VMs, green bits, protected by SMP. So the L1 host isn't trusted. The layers of the container get stored there. Containerd runs there, picks up stuff from untrusted control planes and the untrusted container registry. And then it uses HCS shim to talk across a VM bus connection to the utility VM. And in the utility VM here, we have a guest agent. And in between, we do a bit of enforcement. So the enforcement is over relatively fine-grained commands. Mount this layer, set these environment variables, execute this command, that sort of thing. Here's a quick example. It illustrates the sort of thing we're discussing. So this is a Rego policy. It's got various bits and pieces in it. It kind of looks like configuration if you squint, but there are really rules applied to the configuration. So the host can come along and say, I want to mount these things, and then the guest gets to choose whether or not they get to be mounted. And this is the source of truth of what's allowed. So what's the policy really? How does it fit into our confidential computing? Well, it controls the behavior, and so enables a customer to dictate the behavior of the system, since the customer provides the policy. In general, the policies are generated by tooling, and will take the customer's kind of golden image of a container and the the various features imposed by the Docker file and generate a policy to match, such that it will only run that particular container with those particular parameters. Some of the things can be wildcarded, but mostly it's derived from a kind of a golden version, if you like. That golden image can be local in your box from a Docker daemon, or it can be something pulled from a repository. So we have a policy separate from the platform code. That's essentially an ACI because Azure brings the host OS, the container stack, and the UVM image, and the Linux kernel and user land inside of that. Whereas the customer brings the containers and how they should behave, and they need to change independently. And your trust for the platform and the workload are different things. So, of course, this isn't the only way. There are other approaches. You can just measure all the code. It's typical for smaller enclaves. So we use the SGX enclaves, for example. Yeah, you can measure all the configuration, all the code, but these all end up mixing up the platform and application measurements. And so if you want to run them changes, then it's all very difficult to manage. And it also makes it hard to be sure you're just discussing measurements of a workload and a workload's identity. That's very important to us. The policy on its own is not enough. We need to know that the code that applies the policy is genuine and so abides by the policy. So we do that because we've got a UVM measurement in the attestation report. And so we know that all the code that we're running inside the UVM, the Linux kernel, is the exact Linux kernel that we built and trust. And the user land is all the components that we assembled up into the user land, and they're the components we know and trust. And then separately, the host data field provides the hash of the particular customer policy, and the UVM guest agent will insist it will only accept that exact policy whose hash is that exact number, which is inside of the hardware. The attestation process, once we've done all this, is pretty normal. You end up talking to MAA and MHSM typically in an Azure case. Other key release and relying parties are, of course, available. But to allow for serviceability, we provide evidence about the provenance of the UVM to the relying party. So what we do is I'll get to that. We provide this COSI Sign 1 document that basically contains the measurement and is signed by the team that generates the UVM. And so they're saying, well, this is a genuine UVM. Greg, if you get a thing signed by these people, you can trust it. And he does. And then separately, we have a policy hash, which of course changes by customer. And that's the host data. And that part of the attestation report would typically be checked in the key release policy in the managed HSM. In other cases, I mentioned here, we use CCF, and it puts all the policy, it takes the whole policy and it stuffs it away for future reference. This slide is a kind of when talking to the customer slide. It tells us that the policy dictates all the future states of a genuine UVM. So another way of thinking of that is it controls all the state changes invoked by the host. So the host can only do the things that the customer is prepared to let the host do. So in particular, it can't start mounting things on /bin bash or /bin my application and thus stealing the control. So there's only one path from the host to the guest commands and quite a small number of actual commands. This makes the task of enforcement simpler than it would be for a whole arbitrary VM, where all number of agents are running, doing all sorts of things. So note that we only enforce this over the host to guest API. That's the container path. If the guest's running SSHD and doesn't have any passwords, and you can log in as root, then well, there's no help in them. We are not responsible for that piece. That's for them to make sure that their workload's security stance is proper. So here we have an example with 3 allowed images: a square, a triangle, and a circle. The host requests a circle image. It's on the allowed list, and so it executes and That's it. It's prepared to run the command that goes with the image. Here we have the host requesting the Pentagon image. It's not on the allowed list, and so it's denied. Whilst a lot simpler than a whole full VM, container runtimes are a good number of fiddly ways to influence the state of the guest. The policy encapsulates the allowed ways. Here we have a list of the places we enforce over state changes. As you can see, there's quite a lot of them. Yeah, it's all a bit fiddly, but it's a lot simpler. It's a finite set of interfaces. Well, yeah. Here's an example of a whole policy. I'm going to use my mouse as a pointer. Hopefully you'll be able to see it. So it says basically, I've got some image. It's got an ID. This ID is kind of just an identifier. It doesn't really mean anything. What means something is the actual layers. So these are root hashes of Merkle trees over the expanded out tars that compose a container image. And they must match when somebody tries to mount an image, when the host tries to mount an image, it'll check that the hashes do match. Another example is mounting. Here we've got a rule that allows the mounting of etc. resolve.conf, because that's how we find out how to do a DNS. And again, it must match. And over here we've got the backdoor, where I allow execution of commands, including bash, and thus this is just my work in progress policy.
Hey, Ken.
Yeah.
Hey, Ken, I know you asked for questions at the end if possible, but there's a handful that are appearing on the chat window, and I'm not sure if some folks might be, and you're going pretty quick. I know I'm not following everything myself, and I've been working with this stuff for a while. So
yeah,
I feel it might be reasonable to.
Let's pause a moment. We can go back. Yeah, let's do that. So I can't see your hands. I'm sorry.
Yeah, there's no hands up. There's just a few questions on the chat. So
okay. If you read them out,
maybe
I'll try and answer them.
Yeah, maybe we can start with Dan, who was asking about OSs in all that layering. If Dan, you want to ask your question?
Yeah. So if it's just the host is Windows and the guest is the UVM is Linux, then I think I'm on the same page. Okay.
So the L1, the hosting OS is Windows, and the guest OS is Linux.
Okay, I'm with you.
So that's the UVM's OS, and then obviously all the containers are Linux containers. So the first layer might be Ubuntu, and the next layer might be your application, or it might be you did an apt get inside your Ubuntu image when you were authoring it, and so forth.
Okay, and then unrelated to this, but there's some way to run containers directly on Windows, or it's always a VM that the container is deployed into?
So Windows containers can run natively on Windows, but Linux containers cannot. There's always a UVM for a Linux container.
Okay. All right. Thank you.
If you're using Docker, you're probably running the same stack as this. Maybe a distant relative of it now, but it will be the same underneath.
Okay.
Next.
I have a quick question. So I was wondering for the Windows containers, is it still Drawbridge based ones, about 10 years ago, or it's totally different now?
I think it's totally different now. So somebody else mentioned Drawbridge to me yesterday in a different subject, and it's not a term I recognize. There's a whole bunch of terms named after noble gases, which I think are the current ones. So they've got argon and krypton and something else. But that is for Windows containers on Windows. This technology, LCOW, Linux containers on Windows, is just known as LCOW. And to me, I've been involved with it for a few years, but not 10 years.
Okay, got it. Yeah. Thank you.
So, Osama, you're asking if questions will be taken on the fly. Do you have a question?
Yeah, I just have a quick question about so you mentioned different measurements, and I was wondering like who is measuring, who is actually getting these measurements? And secondly, where does the where do the reference values actually come from? Because the verifier has to compare against something, right? So
Yeah.
maybe clarify a little bit like who is actually measuring all these measurements, and how does the verifier actually get these reference values to measure or to check against?
Okay, so the measurement's done by the PSP, which is this kind of platform security processor, AMD, I think they call it. And it measures the virtual machine as it starts up. So that's the measurement that lets Greg know that there's a reasonable, trusted utility VM when I go to his service, MAA. Right. Then there's a second measurement, which is a hash of the policy. So the host hashes this policy, puts the hash of the policy in a register that's taken up. It's like a property of the virtual machine that's immutable, called host data. And then when I get an attestation report, that host data is in that attestation report. My Go code in the agent, when it's given a policy, checks that the hash of the policy it calculates is the same as that field in an attestation report, and will only accept a policy that matches. So now we know, because we know we've got the measurement of the UVM image, and we know that the UVM image code will enforce that rule that the policy must match the host data value. We know where we stand to begin with. And so if I then go to relying party, the relying party can check the reference values of those two things. Now, and if they're correct, it can pass out secrets. Now, the way it gets the reference values is one of two means. Either you can have a policy in our case, managed HSM that explicitly says this field. So what happens is you take the attestation report, you give it to Greg, he turns it into some claims in a token. You then take that token to the managed HSM, and the managed HSM has a customer authored policy, and it will say the UVM measurement must be this number, and the host data must be this other number, and because the customer will have calculated the hash of their policy. So that's the simplest way, but it's not a very serviceable way. And so there's this extra feature, which is that the UVM measurement is also encapsulated in a signed document signed by some team that Greg knows to trust that signature. And so when we give him the collateral in that form, if the signatures match, he marks his token with it's a compliant UVM, and then the HSM key release policy can say, if Greg says it's a good UVM and the host data is the right value as provided by the customer, then we're good and we'll release the secret. Does that answer your question?
Yeah, right. Thanks.
Okay. Any more?
I think my question was probably already covered by Osama's question, but I got disconnected a little bit, so I didn't get to answer. Sorry about that. I'm just curious, since you mentioned that the measurement is a SMP attestation, is in the SMP attestation, and PSP only measures the initial launch component. What's measuring the image and the container agent and the things like that?
So the container agent is part. Okay, so the either works one of two ways at the moment. Either it's all bundled up and it's in the initial measurement, or the kernel is in the initial measurement, but the kernel command line is the dmverity root hash of a VHD file that contains the user land. So that means that the combined measurement of the kernel and its command line, which is part of the attestation report measurement, includes the root hash, and we know that the kernel is going to enforce that root hash over the user land. The user land contains the guest agent, and therefore we're sure we've got a genuine guest agent.
Okay. So the guest agent is also measured by PSP.
Yeah. So that's, if I went back to, if I'm on slide 16, let me just see if I can just nip back to the slide that's the one that shows an attestation report. So this measurement here starts 2C, blah, 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 blah. That is the initial UVM measurement. And that's either over just the kernel and its command line, or it could be over a bootloader that contained a hash across the kernel command line. We want to speed it up a little bit more. And then the host data is that hash of the allowed policy. And there's only one policy allowed for any given UVM, because the host knows when it's about to start up a UVM, the policy and everything about the workload it's about to start. And so, or pretty much everything about the workload it's about to start. And so it includes that host data in the initial physical state.
Okay, I see. In that case, if we so what's measuring the container image, and if like how can users set policies like what other workload can be running in the same VM?
Yeah. So these, in this diagram, these layers all have measurements attached by containerd as they're downloaded to the thing. So they all contain DM Verity Merkle trees, and that Merkle tree has a root hash.
Mm-hmm.
And so when they're mounted into the guest gets to see the root hash of that layer, and it checks that root hash matches the root hash of the allowed list in the policy. Okay, so the root hash of this layer here would then have to match up with this root hash. Sorry, I'm pointing with the wrong pointer here. Okay.
Okay.
And now this is for one particular container, but this is an array of containers, and I can put in 10 containers if I like. Okay, and any one of those containers, or any number of those, more than one of the, 1 up to n of those containers can run. Mm-hmm. Since this is an allow list. So basically I'm constraining all the future states to say, well, you can run this container that's got these layers in this command line. You can run this other container that's got these layers in this other command line. And if I try and run the first container with the second container's command line, it won't let me. And I can constrain it further by like the environment variables and so forth, so that if I try to give the wrong container the wrong stuff, it will catch you and reject it. So, okay. So you could, and this happens, for example, later I'm going to talk about fragments, I'm going to talk about how we do serviceability, and there's a time when we introduce some policy to allow one of a number of sidecars that ACI use to provide features. And it's done because, well, you can have any number, essentially, of containers allowed.
And it's the agent that runs inside the guest that's going to measure what's actually loaded into the guest. And is that agent one of the guest components from Coco?
No, it's not a guest component from the Kata thing. It's analogous to the Kata agent, but it is it's this thing called, it was once called, it's called GCS. It's a Go program. It's the link, one of the links to it's on the first page to GitHub HCS shim directory. So all this UVM, basically HCS shim and the guest agent are essentially a bridge between containerd and run-c. So in a regular container system, run-d talks more or less directly to, containerd talks more or less directly to run-c. And what's happened is there's this extra bridge to cross the VM boundary between containerd and run-c, which is HCS shim on one side and a thing called OpenGCS or GCS, Guest Compute Service, on the other. HCS stands for Host Compute Service, which is some Windows API. So those messages have to be, containerd wants run-c to do a thing. HCS shim decomposes it into nice little bite-sized pieces that can be sent across the VM bus to the guest agent, which then kind of reconstructs it to give to run-c. And in the middle, we say, are we going to let this happen or not? Does that make sense? In the Kata case, yeah, I was just wondering if my explanation is good enough. In the Kata case, run-c and guest agent are basically the same thing. There's a Kata shim here instead of an HCS shim, and the resolution of the messages that goes across is much more coarse-grained, but it's all logically the same thing. And then there is a version of the policy enforcement that various people in the LSG are doing to add into the kata scheme in a more or less equivalent architecture. Okay, shall I carry on?
I just want to briefly mention, or for me, it took a while, and then thinking kind of through and understanding the simplest scenario and what this policy enforcement model, how it changes the relying party. I knew me personally, having come from an SGX world, I was of the mindset of, okay, as a relying party, anytime I work with it, I am going to get kind of an unbiased, neutral report on, description of a particular SGX environment. And me as a relying party, I'm going to determine whether I trust it. What is the MR signer? What's the what are the other measurements? Do I trust it? What's the hash of the code that's running? And in the model here, the relying party doesn't get a full description of what's running. It gets a description of the policy that was enforced when the container was.
Disappeared.
So Greg, I lost you there for a moment, Greg.
Oh,
Did everybody else lose Greg?
Yeah, I did too.
I thought it was just me,
sorry.
so thanks.
Oh,
Yeah.
sorry. Can you hear me now?
Yeah, we can.
Yeah.
So we got to the relying party only gets to know about the policy, and then you went silent.
Okay, so sorry about that. Don't know what messed up, but I'll speak closer to the microphone. And I don't want to take your time, Kim, but I was just trying to say, for me, it was a kind of an eye-opening moment when my head clicked on the most simplest kind of way to think through it for me, which was, if what I'm trying to say in my relying party is I only trust container X, my relying party code changes, or authorization policy changes from, verify measurement container, hash, equals X, to verify policy, matches, only container allowed equals container X kind of thing. And so you basically need the participation of, you need to have some influence over the policy that is being used to load, obviously, right? Because otherwise you can't just take an arbitrary container and say, does it or doesn't it match my needs? You have to, and those could change over time. You kind of have to upstream your policy, and I think there's some pros and cons to that. It moves it further upstream and can simplify in the relying party, but then there's this coupling that didn't exist before, kind of thing. So anyway,
Yeah.
back to you, Ken.
So essentially, what the point there is that the relying party gets to be a bit simpler. It's just got to check this one value, and the piece that you would have thought the relying party ought to be doing is being done by the agent before it gets to you. So it's the agent that's checking that particular containers are loaded in a particular way and so forth. And we had to do it this way. We didn't really have a choice because, for example, there's no sort of start and end to any of this. The container D can come along 10 minutes later and start up another container. The state is quite a variable thing. We can say, well, any of these 5 containers can run. The first one runs 10 minutes later. The second one runs. One day the second one runs first, and the first one runs second, and so forth. And that's kind of expected behavior on the part of the control plane. Now, if you want really closed down behavior, they can say only exactly this one container can run, and then you'll have a very simple policy, and it'll all just be locked down as it could be. But it saves the relying party having to understand a great number of things. And going back to the other diagram of all the different things that can happen in different orders, I think it would be really difficult to do this any other way. Some of the other systems that do containers only let you run exactly one container. So the Google thing I think it's called Open Space, confidential spaces maybe, it has exactly one payload and no flexibility because of, you can't. you can't have a hash that represents a state otherwise. So let me go back to where we were. So the other thing, so basically what's going on is the agent is checking these measurements. Oops, sorry. These measurements here are the measurements that you expect. And you can see this is quite a simple policy with all bits snipped out of it. If we were to try and pass all this information to a relying party, basically you'd have to implement all the same enforcement logic in the relying party as we do in the Go and the Rego code, and it would be very, very chatty. Or you have to live with constraints like you only have exactly one policy. Oh, sorry, one container. Right. Let me carry on. So here, eventually, so there's two bits of Rego, really. There's the Rego that we saw here, which is basically, this is what we would call a data piece in Rego, and which contains reference values, really, in relying party terms. And that's operated over by some rules that are more sophisticated rules. And this one, for example, is the one that checks that the device hash actually matches an allowed layer. It says for all the containers that we might have, check for all the layers in any of those containers, see if any of them match the layer this input layer that's being offered, proposed by the host. And it comes down to a big, quite complicated, again, framework of logic here. So this is the static diagram of the policy enforcement system, and I'll go through step by step each of the stages. So we start with a policy. There's only one policy that can ever be supplied to a given UVM. It must match the hash of in the host data. So that's the policy here. And next to it, a thing we call the framework, which is basically a library of the policy. So someone about to ask a question? No. Next step, somebody attempts, oops, I've been did I just look at the wrong value? Okay. So that then gets compiled into these policies, the Rego stuff gets all compiled up into these modules, which are actually the runtime things. And eventually, the host tries to mount a device. There's basically a description of the mount command. And here we can see it's got a mount path and a root digest of the thing that's being attempted to be mounted. And that's what we're going to call the input. It then gets passed, the pertinent parts get passed into the Rego code where it's all evaluated against. So now it's input.device hash is device hash from there. And then that gets checked against all those layers that we saw earlier in the input data, the main data, the object data. And then if it's all good, it passes, then we say, okay, we've mounted a device, it's called layer 0, its hash is here, and we store it away for future reference. We have to do all that fine-grained stuff because we do get devices mounted one at a time. So it's not like a great big, here's a container, here are all its layers meta operation. Kata does do that in the Cocoa way. It's easier for them up to a point. But we have to deal with it in fine grain. And then it says, okay, it's allowed, it tells the Go code, allow is true, and off we go. Does that all make sense, or was that too fast? Okay, all right, I'll carry on then. So, okay, it's all great, it's all fine, but it's the real world, things change. So, and yeah, so we invented this thing called fragments. It's a terrible name, but we stuck with it because we couldn't think of a better name. And and once to invent a better name, we'll just say, we've got this name now. So the idea here is we have a fragment is a policy that can be added to the existing policy if the existing policy allows. So here we have part of our usual tool-generated policy, like we saw earlier, and it says that a thing with this feed, basically signed by this party here, this issuer, may be accepted. An issuer could have several different feeds of different things, and you can choose to trust them individually. Okay, And you can, the main thing is the issuer though. So this issuer here is the ACI signing pipeline, and you choose to trust anything that's put into this fragment here. So it's a new piece of policy, and it's just like the regular policy. You can even include more fragments, allow for more fragments in. But what this does, this particular one, means that users can take advantage of the rich feature set of ACI now, and then ACI can still be in control of changing their sidecars, their infrastructure sidecars, without breaking customers. Now, obviously, this expands the TCP. That is a customer choice. Other options, some of which are coming soon, will let you turn all this off, and then you can start using explicit code that might reach out and do managed identities for yourself. But this just basically lets it all just work like ACI always did. Then we have image attached fragments. So that first fragment is inserted, or the control plane will always try and edit, unless you tell it not explicitly. These ones are ones that you attach to a particular image. So the rule says this image called Parma, that's from this feed, which is just a name. This isn't really a URL or anything. One whose feed is Parma 0CR interesting app, signed by this particular signature, which you'll notice is a test one. Allow that in, and if it's not interesting app but evil app, don't let it in. And if it's signed by somebody else, also don't let it in. And then these get attached by using ORAS to the container registry containing some images. If your container wants to download those images, then it will get these too. And so if the ARM template in the case of ACI specifies an image, Ken's image has got an attached interesting fragment, that all those fragments will be offered to the runtime, and if they match this policy, they'll be allowed in. So what that means is I can then update my image, I can get my original policy in terms of these fragments, and then I can spin a new version of my image. And as long as I also spin a new fragment, which is still trusted, then it will automatically be allowed in. I don't have to change my original policy, and therefore I don't need to change the reference value that the managed HSM keeps. So that gives me essentially a stable policy, and thus a stable identity for my workload. Those standalone fragments are kind of like the user version of the ACI infra fragment. We haven't turned that one yet because it turns out there's some plumbing that's very difficult, but it's conceptually identical. You get to say, this allows you to easily say, here's a fragment that that's actually all my policy, and thus you're sure that your policy will never change, or the hash of your policy will never change. And you're basically saying, please run any policy signed by Ken's test DID, and with this label, this feed label. We make extensive use of this DID X509 stuff and the Cozy Sign 1 stuff, and there's some links to help people find out about it. And now I'll ask for questions. I'll try and make it so I can see the screen again.
Yeah, I have a question, sort of related probably to Greg's question previously, where this sounds like it's a launch policy, right? So this is a policy that's enforced when launching the workload and the measurements of that, and it has some hashes or digests for the policy that was used. But does it also provide information about the entity that verifies the signature, the trusted agent that evaluates those policies? So
that's embedded in the UVM measurement. So, and that UVM that's endorsed by a signature, which in our case is the team team called Container Plat. So we've got two teams involved here that sign things. One is the author of the UVM, and one is the author of these infrastructure sidecars. And so what gets passed to MAA is actual measurements, the attestation report, and an endorsement signed by the author of the UVM, and Greg knows to trust them.
Yeah, I think, hey, Ken, so for most folks on the call are not super familiar with MAA or all the kind of details what we're doing. So probably
Okay.
makes, probably would make more sense to more people if the answers were, had nothing to do with MAA.
Okay, so what happens is when we come, there are, let me find, maybe I've got a slide that covers this. I've got this slide. Let me share my screen again, and then I can just drag this on. So
And,
here
and
we
I
have,
think, and I think you're trying to answer two questions. One was, the first question was there a measurement of the agent that enforces the policy? And then the other question you were following, the other question that wasn't asked, I think, but it was the logical next one was, how do I trust it? And I think you were talking about both, and they're different, right?
Yeah.
Yeah. Right. So down here we have a measurement.
Yeah, you're not sharing.
Am I not? Oh, sorry. This is me being useless. Am I sharing now? No, I'm not. Oh, I have to press tip on. Sorry.
Yeah.
So this is the endorsement that describes the UVM. So this has down here a measurement that is the PSP generated measurement for the image, the kernel, the user land, and thus the guest that does all the enforcement. And it's wrapped up in this object, COSI sign one document, which is signed. This is essentially a signature. It's a certificate whose thumbprint is this, and has a leaf whose extended key usage is this. And this is signed by the proper Microsoft signing pipeline, and they promised never to issue this EKU for anybody under the certificate that is not this team that's asking to sign this UVM. Okay, and then this is all the certificates required, the certificate chain and so forth that is required to authenticate that this was indeed signed by this issuer. And so in the relying party logic has to consume this and say, okay, if I've got a measurement that starts D527, and I've got a document that claims that measurement is a good measurement, and then it has to decode the certificates used to actually do the signing are indeed to match that issuer, and then it gets to compare that issuer as a string against the issuers it trusts. Okay.
So this launch measurement is the measurement of the container, or is this the actual of the launcher?
That's a measurement of the whole VM. Go back up to here. It's this measurement.
Okay, and that contains the agent itself. So that measurement includes the agent.
Can you go to the next slide, the slide 5 with the diagram, and point in that diagram to what's measured? I think it's the green.
The green bit is all measured, yes.
That's the launch measurement, the green. And then the host data is the measurement of the policy that's enforced by that red, or that the red enforced item, correct?
Yeah. And of course, the green is measured before all the containers are instantiated. So they're measured before the execution of the first line of code in the VM. So it's basically a static measurement. Carry on.
And it includes that red enforce item, correct? The measurement.
Yeah. So yeah, the enforce part is part of the guest agent. So messages are coming in. The positioning of that is really to emphasize that the enforcement occurs over the message stream. between the HCS shim and the guest agent. The actual code is, of course, inside the guest agent.
Cool, thanks. Did that clear things up, Jim?
Yeah, I'm just trying to understand benefits of launch side policy and relying party side policy. Because
So
what you could look at this, you could look at this one way and say, okay, just let it launch and let it test, and let the relying party decide. Is it trusted or not?
Yeah. The thing is, it's very hard to do that because the container, what are you going to tell the relying party about what happened?
I think what you're saying is containers are dynamic from the like ZSMP technology perspective. It measures the launch of the VM, and containers dynamic. They come and go, right? They're added, create, and so on. So, in terms of that's how do you get that reliable measurement of what's running, right? If it's
So what you end up having to do is you have to say there's a point in time where it can't change anymore. And indeed, Google do this with their container confidential container offering. And what that means is you can have exactly one container. And for the purposes of ACI, that doesn't work because they need many containers. And then typical workloads and the style of container operation is that you add more functionality by adding more containers.
Oh, sorry, maybe I was speaking over a gap.
Go on.
Sorry, the network must be unstable for me, but I was asking where the policy is stored and what the user experience is you're trying for the end user being able to specify their policy through that.
So what happens is that in ACI, and ACI is a sort of subset of possible uses, you describe your container via a thing called an ARM template. It's basically this big lump of JSON that talks a lot about Azure infrastructure. And part of that describes the container. So there's a tool that will go and read the piece of the ARM template that describes the container and generate policy from that will be quite a restrictive policy to exactly that container and exactly its parameters as described by the ARM template. And then inject the policy as a big lump of base64 into the ARM template. That then, when deployed, eventually arrives at container D as an annotation, in fact, and then it gets passed through. So the customer can store that policy any which way they like once it's generated, and they can add it back into new different ARM templates if they think it's going to be compatible. But generally, we would expect them to regenerate. If you get sophisticated, then you'll start separating out the control of the ARM template and the policy. And in more sophisticated applications, we do that.
Okay, let me repeat that back to make sure I got it. So the user is interacting with one of these Azure resource templates. They specify their containers in there, and then a tool will translate those into some sort of policy blob that in turn gets added to the ARM template.
Yes.
And then that follows things around. Okay, thanks.
Yeah, and I think...
Go on, Greg.
Yeah, there's a correct me wrong again, but you pointed out, I think you described there's two ways to do policy. One is, I think, what we just went through, which is a very specific detailed description of a container, a set of containers, that are allowed to run and so on. Or the other is you can apply this indirection with fragments. And I think the tooling you just described works with the direct mechanism. And if indirection is involved, then I think different things have to be done. Is that accurate, Ken?
There is a version of the tooling coming along that will handle the fragments for you. I will wave my arms around about that at the moment. I personally find it much easier to generate a fragment for my sidecars separately to any overly clever thing that scrapes them out of the ARM template. But yeah, so for your use case, I've got some make files that will suit you fine. That you use standalone little tools to go and generate what we need.
All right, cool.
So part of the reason for those, can I just cover a thing? Part of the reason for tooling is, and part of the reason for the need for this infrastructure fragment is there's basically a layer of rules that are a consequence of the ACI control plane. So there's a bunch of things that get set on containers that are set on all ACI containers and therefore need to be added in as allowed. And they're not things that can influence the behavior of most of the containers, but they're kind of essential for a certain class of a container. So we have to kind of abstract away a lot of control plane dependencies into one place, and then user dependencies into another place. So it all does get rather fiddly. Sorry, carry on, Greg.
I see Mark has his hand up, and I actually want to quickly, because we're 1 minute from out of time. So, quick question: do we want to take some more questions in 2 weeks? Do we feel like we have more questions? We want to think about this a bit, or do we want to try to wrap up in 1 minute with one final question from Mark?
If possible, I would like to continue this also. I would like to.
You'd like to continue?
Yeah.
Okay. Ken, does that work for you? Would you possibly be able to come back in 2 weeks and give us another 15 minutes or so of Q&A?
Yeah, I'm sure I will.
Okay.
Greg,
hang on, 2 weeks. 2 weeks. Let me just double check that one. The 23rd. Yes. Yes.
Okay, great. Thanks.
Thomas,
you were saying?
Sorry, Greg. It would be nice to have the recording for this uploaded in the channel so that we can take a look at the presentation again. To have, more.
Yeah, and hopefully Ken can share his slides and we can put them up also in the meantime.
Right. Yes.
All right, we're at 10 o'clock. So Mark, I'm sorry, but I'm going to call time on this. On today's conversation. So I hope you can bring your question back in a couple of weeks. And unless you promise it's 60 seconds or less.
I can hang on 5 minutes.
It is 60 seconds or less. So it's not really a question, it's more for a request. So in the governance SIG, we're looking at the issues of maintaining high uptime of workloads in the face of device upgrades, in the face of workload upgrades, and also the experience of relying party administrators that do not want to change their policies every time some workload is upgraded. So I very much encourage folks with, and you touched on this today, but I would love to have this discussion in the GRC specifically focused on how do we get attestation to work when things change.
Yeah, well, a whole load of this is about that because it's a real cloud, we have real customers, we have infrastructure that changes, and when we first did the first pass of this was very fragile, and we got shouted at by the people that run the systems. And so I think this fragment scheme does alleviate the problem from the relying party to a bit. It might not be a full solution for all circumstances, but we think
we would like
possible.
to clarify these as patterns, and I would love to bring these ideas so we can basically say, look, developers in here and elsewhere do follow these patterns, and you'll have a much better customer experience. I think it's very, very important for accountability.
Yeah. Okay, so I don't appear to be able to share this with the world. I'll consult with Greg and figure out what I'm doing wrong. That means that I can't make anybody be able to see the link. I will do that, and by some means, if not the slides, a PDF or some such, in the next tomorrow sometime, I would think.
All right, cool.
Thank you.
Thanks.
Thank you very much. Okay, bye.
Yeah. Thank you, Ken. That was an amazingly educational presentation here. Thank you very much for doing all the work and providing your time, and look forward to seeing you in a couple weeks. Chairs, if we could briefly hang on for a minute and coordinate next couple weeks out. I think that's Thomas and Jim. I think Keith is not here today. Any volunteers for chairing next time? I think it's naturally Keith's turn, but he's not here.
Uh, I can take this if needed.
You would be, I think, from like to glance at it, you would be the naturally the next person timing wise. I don't mind taking it either, since it's a continuation of, at least the beginning of it's a continuation of Ken's stuff here. But either way is fine, Thomas.
You want to take this, and I will take the other one in a month time, that where Tyler is going to present their attestation, the Verti attestation. That'd be great as well.
Okay. And do we have anything else for a couple weeks out? Because this probably won't take the full hour.
No, not yet.
So,
All right.
Rama here. So there is a proposal that's been pending for 1.5 months. So I believe we have answered like all the questions. So the Jim's comments were pending. Now I have answered that as well. I also answered it last time. So I think we need to find out something to make some progress on that, rather than just keep it pending forever.
So so Thomas and Jim, is this something? I think last time eventually the chairs got all their questions answered, and then we just approved, and then like there was and then a GitHub repo was set up for the work of that particular effort. Is that kind of what we're looking towards getting done here, or is there something else that needs to be done?
Well, I think we need to agree on starting that activity. I think last time I wasn't there, so I wasn't here, so I can't
All
tell.
right. All right, fair point. So we'll dedicate next time. We'll dedicate to finishing up any questions on Ken's work, and we'll dedicate to doing whatever it takes to get through that proposal and take action on it, or get clear what's required to take action on it. And then if we adjourn early, so be it. But that rarely happens.
Okay.
I might not be available next time, because I think I have a talk at OCP. I will be traveling. Mostly I will be not available. So, but there are like Thomas is also a proponent in that. So I believe like you guys can sort out. So I mean, technically it's all resolved. And there is nothing else unless Jim says something is required to be done. So I answered his comment that he had just now. So I mean, technically it's all done. There is just some administrative stuff to be done. Repo be created, because all the chairs have already commented there, so they are all in support. There is a big set of proponents, good community support. KBS is very much interested. Fritz from, no, sorry, not Fritz. I mean, Tobin from Red Hat is very interested in all that, and Samuel is already on board. So I think it's going to be a useful activity.
Thomas, I think you're most plugged into that, to this effort. Do you think there's critical mass without Osama to kind of get through it in a couple of weeks, or do you think we should wait on Osama's availability?
I think we can go without Osama physical presence, because in the 2 weeks we can discuss on GitHub. Everything is already there. So if there's anything pending, we can discuss it there, and then resolve it in face-to-face if needed. But I don't think, depending on Jim, Jim has the only pending comment, so I think it's up to him to decide whether the answer from Osama was satisfactory or not.
Okay, cool. All right, then we'll discuss in a couple of weeks. And Osama, I hope wish you success with with what you're doing in a couple of weeks from now.
Cool. Thanks a lot.
Thank you.
All right. Thanks, everybody.
Bye.
Talk to you in a couple of weeks. Bye.